Welcome to the MFAX booth here at National Electronics Week in Birmingham, UK. I'm joined by Dave Hall, who's the Business Development Manager. Welcome, Dave.
Thank you.
Now, we featured a lot of video clips and different discussions over the last few months on factory automation, Industry 4.0, and the increasing need for metrology within inspection systems. And you've got a really interesting new technology inspection system behind us here, the A3DI, which made its debut, or its production debut certainly at Productronica, and then again in the United States a couple of weeks ago at Apex. Can you maybe, for the sake of our viewers, tell us a little bit about the system, how it works, and your thinking behind it?
Absolutely. The A3DI is a new look at inspection for PCBAs. It's not optical based, it's a metrology based system. We use laser techniques to actually measure components and solder joints against the CAD and against the IPC standards. So one of the great things about that, of course, is when we have a measurement system, we have a near zero false call rate, because it's either in the right place or it's not. It's not a comparative system anymore.
Yes, absolutely. No false calls. And does it? So it measures it in 3D. Does it go up to a certain height?
Oh, absolutely. It's an XYZ measurement system. We use laser scanning techniques to generate profiles. It's extremely quick. We have extremely high resolutions. Our Z resolution is sub 1 micron, so we spot things, very, very small. We have to be almost a bit careful. Sort of fog and dust, show up quite easily on the scans.
So you said your Z resolution is 0.75 micron, so you're 0.4. Yeah. And what about your XY?
That varies, depends on speed and the resolution. We find that we can usually, if we're down to an 0201, we usually run at around about a 40 micron resolution. That gives us the sort of speed you're seeing today. But we can drop that to right down to 100 nanometers if we want to. But typically, if we're doing an 01005, we would run around about sort of 20 micron resolution, and that gives us the sort of the scales we need to get the right sort of measure.
That's pretty good. Now, what about the 2D function? Because a lot of the machines that we see out there today have got 2D and 3D built in. The 2D essentially being for things like barcode reading and reading nomenclature on chips and that sort of thing.
Okay, we do everything in 3D. There's no 2D option at all. That's purely the way we work. Barcodes we tend to read with a barcode reader inside the machine. Reading the value of a chip, is basically still depth, because it's either laser etched or it's silk screened. So it has height or it has depth. So we measure that height or depth, which gives us a very robust way of checking it's the right value.
Okay. So tell me some of the unique applications that you could use this system in.
I think one of the main things is the low false call, but it's also extremely fast. The programming side of it is extremely quick, and it's very quick to stabilize a program. There's no debugging. So we're finding, we've been really fortunate. I mean, we've sold systems into ultra high volume in the Far East, and we recently sold into the Mil Aerospace areas in the UK, which are extremely challenging in the amount of testing or inspection you want to do. So we've done both ends of the spectrum at the moment. So yes.
So, but without getting into any specific jobs, I mean, it has got some very good attributes in terms of being able to work with certain lighting values, where it can see, it can work with different materials that a standard AOI system would struggle with.
Absolutely. It makes no difference whatsoever, the lighting. You'll see the machine's completely open, we can have the lights fully on, we can switch the lights off, makes no difference. It's any sort of shading or colouring makes no difference to the results or the stability of the programming. We've worked with bare die, we've worked with silicon, we've worked with PCBs. Almost any object, we've concentrated on the PCB market because we feel there's a need, and there's a step change in what we're representing.
And now, of course, it plays directly into the Industry 4.0 factory automation with all this metrology giving data up to the systems, but it's also doesn't need an operator, this machine.
There's no position for an operator. There's no decisions to be made. The limits are set on the IPC standards, and we've been doing some trials with the British government and people like Rolls-Royce and the MTC, which is an organisation in the UK, to do some solder joint trials to classify and validate solder joints to IPC class 3. So there is no position for an operator to make a decision. We don't use multiple models. There's one model, which is a mathematical model, not an image. So there's no place for an operator, I'm afraid.
Well, you know, it's a very exciting find for me here at the show, so thank you for telling us about it today, Dave.
Thank you for your time. Thank you.